Number 8 in this list of integrals from Princeton, integral x squared times arctangent x dx. Okay, so hopefully you've seen before the integral of arctangent x dx. This was actually one of the previous problems. That was integration by parts. So just from that in itself, you should have an intuition, hopefully, that maybe integration by parts is a good method to use here. Another reason why integration by parts would be a good candidate to try is because it's a product of two things. Remember, integration by parts is undoing the product rule, kind of. Okay, so let me expand this a little bit because I get put off. Okay, so that's why I'm saying here, try integration by parts because it's a product of two functions, and integration by parts is used to find the integral of arctangent x itself. Exactly what I said. Okay, so we choose a u or dv. U is arctangent x. du is 1 over 1 plus x squared dx. dv is x squared, so then x squared dx, sorry. V is a third x cubed then, okay? Again, why don't we choose dv as arctangent x? Well, that's a hard integral to evaluate. You need integration by parts to evaluate that. So why don't you choose u as arctangent x? Try that first. And then if it doesn't work, then maybe try dv as arctangent x. Don't make your life harder than it needs to be. Okay, integration by parts. So uv minus v du. uv, that's this first term, minus integral v du. That's right here. Okay, so how do we solve this integral now? Integral x cubed over 1 plus x squared dx. There's multiple ways you can do this. You could probably do a trig sub. You can do long division first, and then maybe it'll be a nice rational function you can evaluate, or maybe you have to do partial fraction decomposition. I don't know. I instead chose to do substitution because x cubed I can write as x squared times x. Okay. So then I substitute t as x squared. dt is 2x dx then. Okay. So then I get t over 1 plus t dt inside the integral, and then the constant becomes a 6 because of this 2. Okay, because dt over 2 is x dx, so it becomes a 6 there, okay? Now, over here, what I actually chose to do an algebraic hack. This is very common, okay? So I added 1 on top and then subtracted 1 right away because I'm adding the 0 technically, okay? So I'm going slowly for this because if you've never seen it before, you have a nice tool in your pockets that you can use, okay? So then I rewrite this as two fractions like this. I can break it up, okay? This first term is just 1, and then this term is easy to integrate. Okay, this is what you should get if actually you did the long division from the start. So from up here, if you did long division of this, you should have gotten this actually, just in terms of the variables of x instead, okay? And then maybe a different constant out in front. But you should get something like this, basically. All right, so now we integrate from here. T minus ln of 1 plus t, don't forget absolute values, okay? And then we got to back substitute. What's t? It was x squared. So then this is my final answer. Again, there's multiple ways you can solve this probably. This is how I chose to do it. And again, if you type this into Wolfram alpha, the original integral, this guy up here, it might not spit out exactly this. It might spit out something different. But if you tell Wolfram alpha to differentiate this last line right here, you actually get back x squared arctangent x. So that's how we know we did it correctly. Okay, hopefully this was helpful. Please like and subscribe as always to show your support. And hopefully see you in the next video as well. Bye.